In this question we're being asked to calculate the heat of formation of C2H6 from the following data. So we're given two heats of formations and a heat of combustion there. So we're given three pieces of information. And what we need to do is get the heat of formation of this C2H6 here. So before I begin, I actually need an equation for that. So I need the formation equation for C2H6, for ethane. So to write a formation equation, we put in our arrow first, and then we put our product on the right hand side, what we want to form. Then to the left of that, we write down the elements involved in their standard states. So we have carbon, which exists just as carbon, and we have hydrogen, which exists as diatomic molecules. There are two hydrogen atoms in a molecule. So remember, hydrogen and the secret 7, those are all your diatomic molecules. Now I need to balance this. So I have two hydrogens on the right, so I need 2 on the left. And I have 6 hydrogens on the right. So to have 6 on the left, I need to multiply here by 3. So this here is the equation that we want to finish with. So this is our main equation. Okay, so we'll just put a box around that so that we know exactly how important it is. So that's what we need to finish off with. Now, if we are to look at the three pieces of information we've been given, if we look at the first equation here, so if I was to number them, and we look at equation 1 there. So carbon plus oxygen gives us carbon dioxide. Now I need to find something in equation 1 that matches something in my main equation. And as we can see, what matches there is carbon. Carbon appears in both. So because carbon appears in both, that's what I'm going to focus on for now. So the carbons. So if we just highlight the carbons, just so we know that that's what we're linking up. And we need to make them both appear on the same side as the arrow as each other, and to have the same coefficient in front of them. So if I look at the carbon in the main equation, it's to the left of the arrow. And if I look at the carbon in equation 1, it's also to the left of the arrow. So no change is needed there yet. But if I look at the coefficient in front, in equation 1, there is a 1 in front of the carbon, and in the main equation, there is a 2 in front of the carbon. So I need to make them match. So what I need to do is to multiply equation 1 by 2. So that means everything in that equation is going to get doubled along with the delta H value. Now I can go on to equation 2. So what matches between equation 2 and my main equation? And it's the hydrogen. Hydrogen appears in both. So again, do they appear on the same side as the arrow as each other? Same side of the arrow as each other. The hydrogen in equation 2 appears on the left. The hydrogen in my main equation appears on the left, so that's fine. No change needed there yet. But if we look at the coefficient, we see in equation 2, the coefficient of H2 is 1. There is a 1 in front of there. If I look at my main equation, there is a 3 in front. So to make them the same, I need to triple equation 2, along with tripling my delta H value. Finally now, if I look at equation 3, so what matches between equation 3 and my main equation? And it's the C2H6, the ethane itself. So first things first, do they appear on the same side of the arrow as each other? So in equation 3, the C2H6 is on the left of the arrow. In the main equation, C2H6 is on the right hand side of the arrow. So they're on opposite sides. So that means I'm going to have to flip this equation around. Also, if we look at the coefficients, in equation 3 there is a 2 in front, but in my main equation there is no number in front. So what I'm going to have to do to make those be the same as each other is divide by 2. So I'm going to divide that one by 2 to make sure it has a 1 in front of it, just like my main equation. We need everything to match the main equation, not the other way around. We never change our main equation. So now I'm going to write down what I have actually changed. So we're going to rewrite equation 1 and make the changes. So I need to double everything. So I have 2 C's, I have 2 O2s, and that gives me 2 CO2s. And my delta H value is going to be twice what it was. So if I double minus 393.5, I'll get minus, if this wants to write, minus 787. So that's equation 1 adjusted. Equation 2 now, to adjust that, I need to triple that equation. So I'm going to have 3 H2s. I'm going to have 3 over 2 O2s. So triple a half, you get 3 over 2. And I'm going to have 3 H2Os. And again, because I tripled the equation, I need to triple the delta H value. So that will give minus, don't know what happened there, minus 857.4 kilojoules per mole. And then on to the third equation. So this one's a little bit more complicated because I need to do two things. I need to flip it around and divide by 2. So what I mean by flip it around is everything that was on the left of the arrow now becomes the right hand side of the arrow, and everything that was on the right hand side of the arrow I now write on the left hand side of the arrow. That also means I have to change the sign of my delta H value. So from a minus it will become a plus. Okay? So as I'm doing that, as I'm flipping everything around and flipping that sign, I also have to divide them by 2. So for equation 3, if I'm flipping around, I'm going to write this stuff now on the left, because I need to flip, and half it. So I have 2 CO2s, and I have 3 H2Os. That will give me C2H6 and 7 over 2, because I have to half it, O2s. Okay, so that's that flipped and divided by 2. So what I have to do with my delta H now is I have to change the sign to a positive, so a positive 3119.6, and divide that by 2. And that will give me plus 1559.8. Now I'm just going to draw a line under everything because I'm going to need to add all of this together. And what I do when I'm adding is I look to the left hand side of all the arrows, and I look to the right hand side of all the arrows, and I look for things that I can cancel on both sides. So if we look at the 2 C's that I have, no, not the 2 C's, if I look at the 2 CO2s I have on the left, they can cancel with those 2 CO2s that I have on the right. The 3 H2Os I have on the left can cancel with the 3 H2Os I have on the right. And the oxygens I have here now, if I add that together, if I add 2 and a 3 over 2, that will give me 7 over 2 oxygens. So I have 7 over 2 oxygens on the left, and they can cancel with the 7 over 2 oxygens on the right. So they're cancelled. And as far as I can see, I have nothing else that I can cancel, so I'm going to write out what I have left. And what that is 2 C's and 3 H2s on the left hand side, and on the right hand side I'm left with C2 H6. And lo and behold, that completely perfectly matches our main equation at the top, which is exactly what we wanted. So once that matches, you know you've done everything right so far, and all you need to do is to add up your adjusted delta H values. So minus 787, minus 857.4, and plus 1559.8 tells us that the heat of formation of ethane is equal to minus 84.6 kilojoules per mole.